Students, welcome to my YouTube channel. In this video lecture, I am going to answer questions from sample paper number 3, the 4th edition of RK Bali navigation book. So let's begin with question number 91. DME, the distance measuring equipment, is a dash radar operating in the dash band and transmits dash. So very important, your distance DME is nothing but your distance measuring equipment. It's a The full form is distance measuring equipment. Correct? Now, distance measuring equipment is an airborne instrument, okay, or airborne equipment. So, and the corresponding ground equipment is called a transponder. So, DME is a secondary surveillance radar base, meaning, let's say this is your ground surface. There will be a ground station called transponder. Your aircraft is in the atmosphere. So this aircraft will transmit a radio pulse in all directions. So your aircraft will be deemed an interrogator. Interrogator will transmit radio pulses at a frequency of 1090 megahertz. Correct? The ground equipment or the ground station will be called transponder. This transponder will reply to your interrogation pulses after a fixed delay of 50 microseconds. Okay, so after a fixed delay of 50 microseconds, and at a frequency of this reply frequency pulses will be at a frequency of 1030 megahertz. 1030 megahertz. So that's why TME is a secondary radar. Now, what is a primary radar? Primary radar is the mode of operation in which, let's say this is your primary radar on the ground, it will transmit radio pulses in the direction of your aircraft at a particular frequency. At whatever frequency, this radio pulses will go towards your aircraft, strike the aircraft, and return to the transmitter. Okay, so this is your primary radar on the ground. So primary radar will transmit this radio pulses at a particular frequency f. This pulses will strike aircraft and return at the same frequency f. So this you can see here only one frequency is used throughout the operation. But in case of secondary radar, the transmitter frequency is different, the reply frequency is different. So secondary radar uses two different frequencies for two different purposes. Primary radar uses only one frequency throughout its operation. Therefore, DME is a secondary radar operating in the UHF band. What kind of band? UHF, ultra high frequency, 962 megahertz, 1213 megahertz, and transmits what? It transmits pulses. Okay, radio pulses. Next, question number 92. What type of pressure sensor is used in a barometric altimeter? Is it aneroid capsule, differential capsule, bellows? So the correct answer is your altimeter uses aneroid capsules to register or respond to changing static pressure around it. Okay. Next, if the glass of a barometric altimeter in a pressurized aircraft, very important term, pressurized aircraft, becomes cracked and the static ports also become blocked, the altimeter will overread, underread, read cabin altitude. Now, this is a pressurized aircraft. So, any airline, any jet aircraft, a turbopropeller aircraft which carries more than 9-10 passengers, flies at very high altitudes, mainly above 14,000 feet. So, this aircraft will be pressurized aircraft, meaning the pressure in the cabin, in the cockpit as well as the passenger cabin will be much more than the actual pressure outside aircraft. Now, this is the need. Why? human beings require adequate pressure to function for all organs in the human body to function safely and properly. When you go to higher and higher altitudes, the atmospheric pressure decreases. So this decrease in atmospheric pressure is a danger to human health. So as a solution to that, all our aeroplanes are cabin pressurized. So the pressure inside the cabin will be much more than the pressure around the cabin, that is outside the cabin. So even though the pressure outside the cabin is less, the pressurized aircraft makes it possible for us to fly at very high altitudes, which comes with many advantages like fuel efficiency, great speeds owing to jet streams, etc. So that's why we make use of pressurization in an aircraft. Now, whenever the altimeter, the glass of a barometric altimeter means what? The face of the altimeter is broken and the static ports are also blocked. Now, the static ports are the way through which outside static pressure enter the back of the altimeter instrument. When they enter the altimeter instrument, they will react, this static pressure will have some effect on the aneroid capsules. The aneroid capsules will expand if static pressure is low. The aneroid capsules will shrink if the static pressure is high. And accordingly, we will be shown our altitudes or vertical distances in our altimeter. Now, if the static ports get blocked, that means the way through which outside static pressure enters the altimeter is blocked. If that way is blocked, that path or that road is blocked, so there will be no way outside static pressure can enter the instrument. So in this scenario, the only pressure that will be available to altimeter will be the inside cabin pressure. Since the glass of this altimeter is broken, all the cabin pressure in your aircraft will escape or will flow into this altimeter, and as a result of this, the anaerobic capsules will react to this cabin pressure that is entering in it, that is entering the instrument. And whatever cabin pressure is in the is in your aircraft, the vertical distance or altitude corresponding to that cabin pressure will be shown on your altimeter. In other words, whenever in this scenario the glass of a barometric altimeter is broken and the static ports are blocked, cabin pressure will enter the back of the altimeter instrument. The aneroid capsules will respond to this cabin pressure, as a result of which we will get an indication of cabin altitude. Okay, so if the cabin pressure in your aircraft is equivalent to 8,000 feet, okay, the pressure that is found at 8,000 feet is what is maintained in your cabin. The corresponding vertical distance will be 8,000 feet. So this will be shown to you. If the pressure in your cabin is maintained according to the pressure found at 5,000 feet, let's say. So the cabin altitude will be equivalent to 5,000 feet. So whatever pressure is registered by the altimeter, it is shown in the form of vertical distance, namely altitude. Okay, so in this case, the altimeter will read cabin altitude. Whatever cabin pressure, that much cabin altitude. Mach meter indications are temperature related. Increase with temperature are independent of temperature. So your Mach meter is nothing but Mach meter indication is nothing but a ratio of dynamic pressure to static pressure. Dynamic pressure to static pressure. Okay. So this is independent of temperature. Next, what is actually measured by a Mach meter? Mach meter measures pitot pressure, the ratio of pitot pressure minus static pressure divided by static pressure, the ratio of static pressure to dynamic pressure. So just now I mentioned Mach meter is nothing but dynamic pressure divided by static pressure. Now what is dynamic pressure? Dynamic pressure is nothing but total pressure, which is another term for pitot pressure. So total pressure minus static pressure divided by static pressure. Okay, so that is your Mach meter indications. Total pressure minus static pressure gives dynamic pressure divided by static pressure. So the correct answer here is option bravo, the ratio of pitot minus static divided by static. The international date line is found on or near dash. When crossing the date line traveling west, you go into the dash. So, the international date line is found on or near the anti-meridian of prime meridian. Okay. And when crossing the date line traveling west. So, let's draw the diagram. So, you are going to draw the diagram of the earth with respect to the North Pole. So, you have North Pole here. You are looking at the earth from the top of the North Pole. So, this is your North Pole. This prime meridian, 180-degree east and west anti-meridian, 90 east meridian, 90 west meridian. Okay, now your international date line is not strictly your 180-degree east-west anti-meridian. International date line is a line which is artificially made so as to adjust for different parts of the country, that is spanning across 180-degree east and west. So 180-degree east-west anti-meridian will be an imaginary straight line. But if you look at the atlas or your globe, the international date line will be somewhat coinciding with 180-degree east-west anti-meridian. At some places, it will be deviating from that. So that is your international date line. So it's nothing but an adjustment made in order to have all parts of the country to fall either to the east of anti-meridian or the west of anti-meridian. Okay, so that is an adjustment. So international date line is found on or near meridian, anti-meridian when crossing the date line traveling west. So you're traveling westerly direction. Now on the earth, all westerly directions are clockwise. Westerly directions are clockwise. Easterly directions are anti-clockwise. Okay. So when crossing the date line traveling west, you go into the next day, the previous day. So when you are traveling a westerly direction, so when you travel a westerly direction across this 180-degree west-east anti-meridian or international date line, you will enter the new hemisphere, which is the eastern hemisphere. Now we all know, we have learned this in time chapter many times, that eastern longitudes are well ahead in time compared to the western longitudes, right? We have eastern longitudes always we have the first sunrise happens in the eastern hemisphere. After that, it follows with after that the sunrise happens much later in the extreme west hemisphere. So when you travel westerly direction, cross this anti-meridian, you will enter eastern hemisphere, and in the eastern hemisphere, the day will be much ahead of the time and the day in the western hemisphere. So the correct answer is option Bravo. You will be international date line is nothing but found on a meridian, not a latitude. Okay, so meridian, and when you cross that date line traveling west, you enter the next day. You enter next day. Option Charlie. Okay, because eastern longitudes are going to be ahead in time compared to their western longitude. So you enter next day. An airborne instrument equipped with a gyro with 2 degrees of freedom and a horizontal spin axis is an artificial horizon turn indicator DGI. So the correct answer is option Charlie. A DGI is an airborne instrument with 2 degrees of freedom and a horizontal spin axis. What error is caused by movement of the gyro relative to the earth in a DGI? So that error is called transport wander. So do read RK Bali gyroscopes chapter. You will find short crisp notes about of the gyroscope chapter in the Oxford in the RK Bali. That is sufficient. So transport wander is caused by movement of the gyro relative to the earth. Gyroscope rigidity is increased by revolutions per minute and concentrating mass at the dash of the motor. So whether you will concentrate the mass in the center of the motor, somewhere at the periphery, that is along the boundary of the rotor, where. So the correct answer is Bravo. Gyroscope rigidity is increased by increasing revolutions per minute and concentrating the maximum mass at the periphery of the rotor, boundary of the rotor. So option Bravo. Rim stands for boundary or periphery. Okay, that's it. So this concludes the lecture. I hope you have understood the questions that I have answered and explained in this video lecture. I wish you all the best. Do watch next video lectures in which I have solved questions from next sample papers, namely sample paper number 4, sample paper 5, sample paper 6, so on and so forth. Don't forget to subscribe to this channel if you haven't yet. Share this video with all your friends who are preparing for various exams. Hit the like button if you have liked this video lecture. I'll see you in my next lecture. Thank you.